Hello folks, today we're going to talk about the combustion of hydrocarbons. So you'll remember way back with the energy sources unit, we learned about what a hydrocarbon is. Remember, it's just something that's made of hydrogen, hydro, and carbon. So hydrocarbon, made of hydrogen and carbon. So combustion is when we burn these things. The most common hydrocarbons are in things that we use every day, like fossil fuels. So to get to school every day, I have to put gas in my car. That gasoline is a hydrocarbon. To make sure that I can turn on my lights to get electricity, we burn things like coal and natural gas, fossil fuels. So fossil fuels are hydrocarbons. It means fossil fuels are made of hydrogen and carbon. So this crap, this stuff, these emissions, which would be the technical word, these emissions coming out of either like your exhaust pipe or the smokestack of a coal burning power plant is how we get all this air pollution in the first place. So by burning fossil fuels, we're contributing to air pollution. So let's take a look at how this happens from a chemical perspective. So here's a picture of a simple hydrocarbon. This one is technically methane, I think, but we could just pretend it's gasoline. So pretend we're talking about gasoline here. In order for my car to run, I need to burn my gasoline. That's what's happening in my engine. The engine is burning my gasoline to make energy for me to be able to drive. So gasoline is the hydrocarbon that will be combusting in this example. So we have a hydrocarbon here. It can be any kind of hydrocarbon. And in order to have a fire, we need oxygen. So that's why, like, if you want to put a candle out, you can put a lid over it, the candle will go out because flames need oxygen in order for fire to exist. So we have hydrocarbons, we're adding oxygen, and voila, we have a flame. So this is a combustion reaction. All combustion means is burning things. So we're burning, in this case, a hydrocarbon, like my gasoline in my tank of gas. So when we do a combustion reaction, because of the law of conservation of energy, nothing is created or destroyed, it just gets rearranged. Hopefully you learned about that in middle school. So you'll notice in the reactant section, we have 1, 2, 3, 4 hydrogen. In the products, again, we have 1, 2, 3, 4 hydrogen. In the reactants again, we have 4 oxygen. And in the products, 1, 2, 3, 4 oxygen. There was 1 carbon. In the products again, 1 carbon. So we don't add anything, but what we have just got rearranged. So when we burn these hydrocarbons, we get 2 specific things, carbon dioxide and water. So you can burn any kind of hydrocarbon and you will always get carbon dioxide and water. So no matter what kind of hydrocarbon you're burning, you will always get these 2 things. What are they? Carbon dioxide, CO2, and water. So no matter what so like we saw in a lot of your presentations, CO2 is a major problem. It's what's causing the majority of the global warming problems that we're seeing right now so like you can see from this pie chart, the majority of hydrocarbons that we are combusting is for electricity. So because we're combusting so many hydrocarbons like coal, natural gas, petroleum, because we're combusting so many of these fossil fuels, we're producing a ton of CO2 emissions. So 38% of CO2 emissions come from electricity sources. 32% come from transportation. So planes, cars, trains, all of these things still run on fossil fuels. And then less so, but still a factor for CO2 emissions would be things like industry and residential places. So the vast majority of all CO2 emissions are coming from electricity and transportation. And in this graph, you can see the impact. We've seen this picture a few times now, and it's really probably one of the most important pictures that you'll see this whole unit. So this is a graph of global actually carbon dioxide emissions since we've really started burning fossil fuels. So the Industrial Revolution happened in the early 1900s, which is about right here. So you'll notice that since that started to happen, CO2 emissions have slowly been increasing, but in recent years, with the advent of population growth and basically everybody having a car these days, you can see that the graph just went really exponentially higher. So I'll say it one more time just because this graph is so important. So climate change, there's the debate of whether or not it's happening and the debate of whether or not we are causing it, we as in humans. So you might be able to make the argument that, yeah, as you can see, before CO2 was even a factor, before we were even really burning fossil fuels, the climate was slightly changing and it was starting to get a little bit warmer naturally. So there was a natural change in the climate getting warmer. But what the reason that scientists say that humans are making it worse now is because since we've started burning so many fossil fuels, the CO2 emissions have increased exponentially, which then goes on to cause problems like global warming. So, in summary, yes, maybe the climate was warming naturally to begin with. Maybe that climate change was already happening, but humans are making it worse by burning all the fossil fuels that we're currently consuming. The only way to stop this trend is to reduce our CO2 emissions. So, to find ways so we don't have to burn fossil fuels like coal and oil.